First, let's define what we mean by memory management. Memory management is the process of increasing conventional memory by loading device drivers and TSRs into upper memory. If that doesn't mean much to you right now, that's okay, because that's what we're about to discuss. Actually, memory management only comes into play with the following operating systems: DOS, Windows 3.1 family, which would also include the Windows 3.11 and Windows 3.11 for workgroups operating systems, and the Windows 9X family. And the Windows 9X family includes Windows 95, Windows 98, and even the Windows Millennium Edition. All of these operating systems fall into the same memory model. They have conventional memory, which is the first 640K of memory addresses, or 640,000 memory addresses. Then upper memory, which are the memory addresses from 640,000 or 640K to 1024K. And then extended memory, which is any memory above 1024K. 1024K, by the way, is also 1 megabyte of memory. Then we have what's called expanded memory. Expanded memory is a totally different type of memory. It's actually accessed in 16K segments by a window in upper memory, and it falls outside of any kind of a linear addressing of memory. We'll talk about expanded memory in just a few minutes. To further complicate things, some of the older 16-bit programs work only if they can use certain memory addresses. And memory management in DOS and Windows 9X presents limitations because their applications use the standards which were presented to the industry when DOS was first introduced. The greatest limitation of DOS is its commitment to maintain the backward compatibility with older software and hardware. In other words, when Windows 3.1 came out, we had already fallen in love with our DOS applications. So Windows 3.1 had to be able to run our DOS applications. Then when Windows 95 came out, we had already fallen in love with the applications that were on Windows 3.1. So Windows 95 had to be able to run those applications. Because of that, we stuck with the same memory model for quite a while. Let's review the memory map. The first 640K of memory is called conventional memory. This was designed in the 1980s, but it's totally inadequate today due to the fact that most applications are very large, that we're running more than one application at a time, and that we're using a graphical user interface which takes up memory itself. The next 384K is called upper memory. If we want DOS to run correctly, we need to load any device drivers and any TSRs, or terminate stay resident programs, like for example Smart Drive, into upper memory instead of into conventional memory. This will improve DOS's performance quite a bit. In fact, in the 1980s, some businesses made their money just making programs that would allow us to manage our memory better. Extended memory is memory that is above the 1024 limit. We have much extended memory. We have a lot of extended memory in the computers that we have today. It's managed by the operating system, and the amount is limited by the RAM and the number of supportable memory addresses. Expanded memory happens when we move data out of extended memory and into upper memory just in time for an application to use that memory. We also have memory that is not in physical RAM. This is called virtual memory. Virtual memory is hard disk space that's used when a system starts to run low on RAM. It's used to increase the amount of memory available, but it works at a slower speed than real memory. And it's only available if an operating system operates in a protected mode. The opposite of virtual memory is also possible. This is called a RAM drive. In a RAM drive, a RAM area is configured as a virtual hard drive so that a frequently used program can be accessed faster. For example, a print spooler, instead of using a hard drive, which would be slower, sometimes uses a RAM drive, which is faster. Next, we'll take a look at specific files that are used to manage memory in DOS.